I'm Dr. Rob.
And I'm Dr. Zenin.
And I'm Dr. Barry.
And today we're going to talk to you about something that's really cool.
Graphene!
Graphene is a single layer of covalently bonded carbon atoms in a honeycomb grid.
Graphene sheets are very useful, but it is difficult to separate them into single layers.
Almost as difficult as it is to separate me and Bart.
But it's worth the effort, because graphene is really strong.
100 times stronger than steel.
Whoa!
This is because it's a network of very closely bonded carbon atoms.
If it's so strong, it must be really heavy.
No.
It's 7 times lighter than air?
I don't believe it.
Well, actually, graphene in aerogel form is extremely porous. The air in the pores are the only thing that holds it to the ground.
Okay. What's an aerogel?
An aerogel is a gel that's had all liquid replaced with a gas, like a solid smoke.
But how do you make an aerogel?
An aerogel is created by taking a solution of an organic substance and allowing it to gel. This means that a lattice forms between the organic molecules saturated by the liquid in solution. The gel is then frozen and the water is sublimated out, leaving the carbon lattice.
Graphene is created. This process is done to suspend a single layer of graphene over carbon nanotubes.
Graphene's mechanical strength and lightness isn't all that's cool about it. It's also a great conductor.
But ain't it covalent?
Yes, but because graphene is only a single layer of carbon atoms, the overlapping pi bond electrons become delocalized and thus can conduct electricity.
So cool!
This means that we could use graphene in extremely small phones and charge these phones in nearly 16 seconds.
In addition, electrical cars can also use graphene technology in supercapacitors to make them a more feasible mode of transportation.
It's currently so hard to create graphene. Researchers are looking into ways to break down graphite into 1 atom thick layers to create graphene.
Sound is one way to do this. Basically, when graphite is placed into water, sound can be used to create extreme temperature and pressures to initiate special reactions to separate graphite.
But listen to this. The separate graphene layers miss each other a lot. If left exposed to air, the air molecules will disrupt the particles between the graphene, and the graphene will restack like a happy family.
Aw, so cute! When it is created, though, graphene is not flawless. Despite its immense mechanical strength, it has the tendency to break like glass rather than bend like steel.
As of now, we do not have the ability to make perfect graphene. This does not matter as much in terms of electronics, but it does have an impact in physical strength.
Perfect graphene can withstand up to 100 gigapascals, while the graphene we can create right now can only hold up to 4 megapascals.
Graphene has the potential to change the world! Be making our electronics super small.
Using nanoribbons that have no resistance at all.
Or even in electron microscopes to make images clearer.
Or even throw them in a couple buildings. Why not? They'll be tough. Graphene
Is the future!